Everybody has the one that's got that confidence interval stuff we did together, and on the other side is all the 5 steps of hypothesis test explained and written out. So we got that. It's a very good one to have next to you when you do homework. So just to make sure, I said this last time, if I'm you, I might start my homework off in section 9.5, because then 9.1, 9.2, 9.3, 9.4, they kind of break every section down and get a little deeper into each one, and they talk about little side things like the types of errors, so forth. We haven't talked about those yet. I like to kind of do that backwards, because once you get talking about hypothesis tests and what the steps are, then you can start talking about some of the side stuff. Well, what could go wrong? How could we be wrong? And that's the types of errors and so forth. All right, cool. Everybody's got that stuff. Anybody else need a copy of the one we did? We did one side of it last time. Maybe the other side to do yet. So, who feels comfortable enough to say what the main idea is behind a hypothesis test? What's the heart of a hypothesis test? There's 2 steps that are like the heart of it. Like, ain't no way I'm touching that, John. All right. I understand. What's, so remember the very first thing we do is look for a claim, right? And really what we end up doing to get a hypothesis test rolling is we say, okay, what if the claim is right? What if the middle is that number, whatever the number is? What if the claim, the claim was, we think the mean is, greater than or equal to 10. So which one would that be? Which one of these would that be? Now, if you weren't here last time, you're like, you got a chance for that one, but that's the null hypothesis, affectionately known as the HO, and this is the alternate hypothesis. In other books, it's called HA, so then you have the HOs and the HAs, but we have the HOs and the HIs. The HO is the one that's always got the equal sign in it. Does this one have an equal sign in it?
Yeah.
Yes. So therefore, that's got to go in for oh. So it's going to be mu greater than or equal to 10. So then the high, whatever that goes in for, the other one is the opposite. So what's this one going to be? Less than 10. And so how many tailed tests will this be? 1, which explains why the t-score chart has that 1 and 2 tail option. So this would be like a tail over here. Now, so what do we assume is true to get a hypothesis test rolling? We assume that the mean is 10. Because then we're trying to show evidence that it ain't. So we go, okay, let's say we have a normal distribution with a mean of 10. How likely is it that the sample I take would be where it is? That's the whole idea here. That's why this is assuming that I do have a normal distribution, which kind of validates every step I take. Right? So I'd say the mean is 10. I assume I have that's the true mean. And then what I want to do is I want to take a sample. I want to see, if I take a sample, where does it fall? So every step kind of explains itself. Well, if I want to see where it falls, and it's all about, if it falls too close, that's not good enough evidence. If it falls far enough away, that's enough evidence that the mean is in the wrong place. So then it really comes down to what is far enough away. So to be honest, the alpha idea, it's not made up, but you don't see alpha referenced in any research paper, any scholarly article, any research analysis results. You don't see any of it. You don't see alpha anywhere. You just see the p-value. The alpha is what you come in with. Well, I need alpha to be less than 0.05. I mean, I need alpha to be 0.05. Whatever the amount of evidence you need. And it could be different for everybody. right? So the book gives us an alpha just to kind of get us going. So alpha describes what far enough away is.
Sorry.
Wow. It's like a loud but half of a sneeze, so it all averages out. So the alpha indirectly tells us how far away is far away enough. I have to look up the z or t, and that's going to be how far away is far away enough. Okay, so I have a feeling about a certain number. I say, okay, let's assume that that number is the reality, and let's see if we have enough evidence to say that this is true. Now think about this. If that's my claim, do I want to find evidence that this is wrong? If this is me, if I feel this way, do I want to show evidence that this is right? Do I want to support this? No, I actually am kind of rooting for the sample to not be far enough away. So I don't always want to succeed. I don't always want to get in here, right? It just depends on kind of like which one am I kind of rooting for to happen, right? Okay, all right. So what we're going to do today is we're going to do that other side of that one paper. I've got 2 more examples after that, and then I've got a little group assignment for you guys to tackle, as I often do. So let's transition to that paper. Do I still have any left for myself? That's a good question, Jeff. The one I gave out last time, we did the one side. Yes, I do. Yeah. Say again? By the way, David Coleman stayed logged in. We can figure out later what we can do to him. I know who David Coleman is, so send an email to the president. All right. This is what we did last time. We set up the hypotheses. The claim was this one. Greater than we thought it was increased. So forth, so forth, so forth. All right, so let's look at the back side.
Is a test on Twotailed if it's equal to?
Do it again.
Is a test on Twotailed if it's equal to?
Yeah, either like what I try to tell people is if you see directional language, what this shit is that? If I say I think it's increased, that's a direction. If I think it's less than, if I think it's gone down, if I think it used to be more, if I think it's at least or at most this much, that's directional. That's going to be a one tail. If I don't see that, it's more than likely 2 tails because 2 tails can be hidden real easy. I think the mean is 7. Well, all right, how many tails is that? Well, what? Mu equals 7. The opposite would be mu not equal to 7. So anytime your H1 is not equal to something, 2 tails. Because how many ways can you be not equal to something? Bigger or less. That's why that would be 2 tails. Either way would show evidence then. So H1, let me back up. Can I prove the mean equals something by just taking a sample? Think about it. If I just take a sample, can I prove that can I use that to show the mean is something? No. That's why we put the equals to here always, because then we say that the high always sets up my rejection region, always. Because that's the one I could show evidence for. Can I show evidence that the mean is less than 10? Oh, hell yeah, right? If I take a sample of 1,800 and I get a mean of 2, that sounds like it's probably going to be good evidence that it's less than 10. So I can show evidence that it's not something, but I can't show evidence that it is equal to something. I can't do that. All right. That's why we decided to do it the way we did. That's the only reason. Okay, so read through this problem. See if you can't figure out what the claim is. Try to write it down in mathish. And again, if you need to borrow a calculator. Oh. Sure. Oh yeah, just a second. guys find for the claim? No, it's not a claim. That is a statement of fact. The average credit card debt 2 years ago was $906. There's no claim being made. It's just a reality. And you can Google that. We believe, all right, that sounds like a claim. We think, we feel, we believe, we claim. That would be a real good giveaway. We believe this debt has stayed the same. Oh, so you're right. The mean is not. I forgot what it was for this one. So, since we think that it stayed the same, then the mean is the same as it used to be. You're good to go. My apologies. So, which one is that going to be, the HO or the H1? HO. This seems like what I was just talking about. So, what's the H1 got to be? So, mu not equal to 906. Is it going to be a one or two-tailed test? Yeah, it's going to definitely be two-tailed because not equal to could be less than or greater than. So the null thinks it's in here somewhere. The high says it's going to be out here somewhere. So we're going to have a two-tailed test. All right. So recall that first step. You find that claim first. It goes somewhere based on if it has an equal sign or not. And then the other guy is going to be the opposite of just what I just wrote down. How do I tell if I'm going to use a Z or a T? Or nothing even? Which standard deviation do we have? Sample standard deviation. S known, not sigma. So that seems like so far what? But what else do I need true? Or it's got to say it's normal, or the sample size has got to save me. Does it say it's normal? No. What's the sample size? 81, which is greater than 30. Check. So it is normal, but I don't know sigma. I only know S. Therefore, I have to use t-scores. T-scores were invented to cover my S for when I don't know sigma, when I only have the approximation to that S. How are we doing so far?
Great.
Fantastic. That's the answer I normally give. So that averages out to pretty good. All right. So the rejection region. The main thing I got to know for this is alpha. So thankfully I know alpha is what?
Point.
Yeah, what's the other name for alpha?
A. I don't know.
I love it. Or little fish dude. Little fish dude. No.
That's the standard deviation?
No.
Alpha.
That's sigma.
Wait, what?
That's sigma. Different part of the Greek alphabet. What's the other name for alpha? It's three. It's No. I like it. It is. That's what it says. It's what it tells you. But it's also known as the level of significance. So I might, the problem in the book or in the test or in the homework or on a quiz or whatever might say the level of significance is 0.01 or something. That means alpha equals 0.01. So alpha is 0.02 in this case. It's a two-tailed test. T-scores, right? So what I have to know to be able to use a T-score, what I have to know to use that T-score chart, I have to know what tells me where to stop. Degrees of freedom. What's the degrees of freedom?
40.
Say again? 40? No? It's always n minus 1, and what's n? 81. All right, so if you get your T-score chart, I have a couple, so I need one. Alpha's 102. It's a two-tailed test. So look, two-tailed test. .02. If it was a one-tailed test, I would have gone crazy because there's no .02.
To the bottom, right?
No, if I go all the way to the bottom, I'm going to get a z-score.
Oh, never.
We have to get a t-score, so that means I'm going to stop somewhere. Where am I going to stop? 80. So if I stop somewhere, I get a t-score. If I go all the way to the bottom, I get a z-score. So stop at 80, 2.374. I like it. So that's why that t-score chart kicks so much ass. When we did confidence intervals, we could have done either one based on if I cut that thing in half or not. Here, it depends on what kind of test is it, a one-tail or a two-tail test. So 2.374. So what's that mean? How's it going to look then? Mine looks like, I don't know, looks like it's had some trouble in his life. This is a normal distribution that's had some freaky things happen to it. How many tail tests again? Two tail. So what's this? Yes, negative 2.374. What's this? 2.374. Yes. That's sort of related to that plus or minus confidence interval thing. Symmetric, so I just find out the number and then I put them in. How do I say this in words? Here's the rejection region visually. How do I say that in words? If. What do I reject it? If what? If T star is?
Not between those two?
No, if it's between those two, I fail to reject. If T star is bigger than 2.374, or T star is less than negative 2.374, we can do what? Reject the hoe. Support the high. So again, you guys get so, I don't blame you for this. You get so wrapped up in the little details. But what's the whole idea about trying to show evidence for the high dude? What's the high dude say? What's the alternate hypothesis for this problem? What's it say for this problem? Not equal to. I like it. How do I show evidence for it not being equal to? I have to show it that the sample is so far away from the middle. Isn't that captured in the picture?
Yes.
So far away. Well, how far away? At least these far away in either direction. So if my sample score is more than this, further away than that many standard deviations, or further down by that many standard deviations, bam, I can reject the null. I can support the alternate. It looks like it is different from the middle, from the supposed middle. All right.
Question?
Yes.
So can you explain to me again how you can tell whether it's a one or two tail test again?
Do you probably be better if you were looking this way. Do you agree with our HO and H1?
Yeah.
Oh, cool. Then how do I show, what does not equal to mean? You can either be, so if my weight is not equal to 190, that means I could either be less or more. So that's why it's two-tailed. Less or more. Right? If the claim was, somebody weighs more than 190, then it would have been a one-tail up. Because that's the only place that would show evidence. I like it. Since it's not equal to, then either direction would show evidence. Yeah.
So that's the only time you know when it's two tails?
Two-tail would mean this means two-tail.
Okay.
I like it. So how can you get here? Either the claim is it's the same, which means it would be equal to, or the claim is we think it's different, or it's changed, or it's not
So
this
it's
anymore.
always second tail.
Say again?
So it's always second tail? Two tail. I mean two tails.
If this is not equal to,
Okay.
then it's two-tail.
You see the claim is equal. It's not using the bigger than less than.
Yeah, there's no direction that I have to specify. Either way would work. Right? So if somebody said, I think exactly 20 people in this room has watched the Game of Thrones. How could you show they're wrong? I think exactly 20 people have watched it. That you can show either more than 20 or 920, and then they'd be wrong, right? That's exactly the idea. The claim is we think it is this, it's the same. So now I want to show, no, it's less than that or greater than that. So either way would work. That's why it's two tails. Okay. So now let's see why this makes sense. We just set up what far enough away is after stating why it is that we're using t-scores. And then, of course, after stating what the hell we're talking about in the first place, right? So what are we talking about? What can we use to talk about it? What's far enough away? And, of course, the next step makes sense. It's, did we make it far enough away? Let's actually calculate how far my sample got from 906. If 906 is the real mean, then any sample that I randomly select should have a mean close to this. What's close? Well, anything within these two is close in this problem. Right? So if I get further from those, that's evidence that the mean isn't 906. Does that, what that part make sense? Okay. So, all right. So what do I know from the sample? I know x bar is, I know n is 81. I know x bar is 80.34. I know S is 106.25. So there, I have to do this. Now this is where students get a little freaked out, which tells me they didn't understand what was going on before. I have to do this, of course. What is S? S is from a sample of 81. It's how spread out those individual students are from their own average. What do I need now? I need the standard deviation for groups of 81, not individuals. So I still have to change that by dividing by the square root of n. S is just an approximation for sigma. So anything I'd have to do to sigma, I have to also do to S. It's just an approximation. So I take 106.25 divided by what? Square root of 81. Yeah, 11.806. Okay. Yeah, I suck. You're wrong with third decimal place, Jeff. And then I just make your. Now, here's why I personally have to be careful. I sometimes just say Z star no matter what. And students are like, no, we're using t-scores in the problem. Who gives a shit? They both measure how far your sample got. So which one you call, it doesn't matter. The formula stays the same. The formula is always my data, 880.34, minus the supposed middle, 906, how far apart those are, divided by how big the spread is, to see how relatively far apart they are. What is it? Somebody save me. 2 point what? 173. 2.17. So that's my T star. Where is that on the picture? What's it? What is it?
Negative.
Negative. That's cool. Yes, it is negative. So then where is that on the picture? Did I make it far enough away? What's right in the middle? 0. Yes, of course. Right. These are t-scores, so right in the middle is 0. Where's negative 217?
Oh, wait from that.
Did I make it far enough away? Did I? No. Hell no. Negative 217 is not less than negative 2374. Right. Negative 217 is like right here. So is that evidence that I succeeded in showing evidence? No. That's not far enough away. It's right in the wheelhouse of what the null thought would happen. Now, so you could say that, well, that's pretty damn far away. And that's why we do this. You ready? If you really feel strongly about this, and you're like, well, I got freaking close. What are you going to do? I'm going to take another sample. Maybe a little bit bigger sample. Who knows? And try again. I'm not going to say I accept the null. You never say accept. Never. Right now I'm going to say, I failed to reject you today. No. Right? But tomorrow, watch your hands. So, right here. You either, now if we make it, we say reject the null. So if we don't make it, we say fail to reject the null. Well, nail, I love it. Fail to reject the null. Fail to reject, reject. Fail to support the high. So remember last time we were saying, we made it in the rejection reason, so we rejected the null, support the high. These are opposite statements, so if I can say one looks wrong, I can say the other one looks right. Well, here I fail to say he looks wrong, which means I fail to say he looks right. Which one now? How are we feeling so far? I mean, if you were not here yesterday, not yesterday. You're like, man, that was a rough day to miss. Yes. Thankfully, your teacher records the lectures. Sometimes even has the camera pointing in the right direction. Which one of these is my claim, the ho or the high in this problem?
The ho.
The ho. So what language am I going to use? The one that talks about the freaking ho.
We failed to reject. The ho.
So let's convert this into correct language for the conclusion.
Yeah.
We have not, what? Found sufficient evidence to,
We have not found what?
we have not found sufficient evidence.
Oh.
I don't like the word sufficient, so I just say suff. Sufficient evidence to reject. See, everybody is always like, how do you know what to say? How do you know I just picked something and hope I got a 50-50 chance? I'm like, well, you got that probability right. But shit, it's not that hard. You just talk about the claim. Cross through the one that's not the claim. Circle the one that is. Use that language. Fail. We have not found sufficient evidence to. That's what that becomes. Reject the claim. That what?
The average credit card debt for all students in college with credit card debt 2 years ago since.
Woo! Average credit card debt. Be careful now. It's not talking about 2 years ago now. The average credit card debt has stayed the same from 2 years ago. Something that tells me you realize this problem is talking about a real world something. Not just numbers, not just HO and H1, but a real situation. This is what they mean when they say it's been clinically tested, right? When they say our product cleans faster than, it's been clinically shown. Well, that means they did a hypothesis test. They found enough evidence to show that it does clean faster or whatever, right? Yes? Okay. Anything else from this one here?
So if it said, we believe the debt the debt is different,
Yes.
then we would be picking.
We would have
fail to
used-
support high.
We would have used this language.
Yeah, right.
We would have said we have not found evidence to reject the claim that.
Oh, okay.
Yeah. I'm sorry. I just wrote support the claim that. Yeah. I love that I wrote reject it. Yes.
Do we have to put all students, or is it just students?
I didn't even put anything else.
You know what I mean?
Yeah. This would be for all students in college with credit card debt. That's what it's referencing. Yeah. I love it. You would never say we have not found sufficient evidence to reject the claim that the average credit card debt for the students in our sample. No, it doesn't make any sense. I know everything about the students in my sample, right? So I'm not gonna write a conclusion. So this has got to reference the population. Yes.
For C, why did you put 0.02? Like, what does that have to do with all that stuff?
All right. Well, first off, it says it right here.
Yeah.
And then why did we do 2374? Why did I look at this column to get 2374?
Just to get the number?
Why didn't I look at some other column? Well, let's look at what this column is. This column is Twotailed 0.02. Oh, shit.
So you have to put it when you're doing the problem. Right?
So how did I get that number that tells me what's far enough away? I have to know what alpha is so I know which one of these to look at.
Oh,
Yeah. And I really, really want you to understand the z-score move. When the z-score moves, there's more or less in the tail, right? So if I made alpha 0.05, that z-score should, or in this case, t-score should be less than what it was because it's coming in. So if I look at 0.05 for 81, for 80, sure enough, it's 1.99, not 2.374, right? So that's the connection between these two. If I have only 1% in the tail, am I not further away now? 1% in the tail, I'm further away, so that t-score would have been larger. 2639 versus 2374. So that alpha controls how big the tail is, which controls how far away the edge of it is. That's the connection. All right. Now, let me reinforce a couple things. Well, actually, let's do this next problem, because then I can talk about this. What next problem, Jeff? Well, the new handout for today. Wanted the first one. Let's see, can I do this one? I think we'll do... Nope, both of these are t-scores. Bless you. No, this one's... Bless you. You do this. Good. Do all the...
So as part of chapter 9, you have to do something.
No, that quiz was chapter 8. Only chapter 8. That quiz on Monday is only chapter 8. I had to look up. It's been a while since I created this one, and I had to make sure they still made Ford foci, Ford focuses. They do indeed. I had a little Ford Focus. It did pretty well for a few years, and then it really just died completely. Okay. So we're going to do these two semi-together, meaning we'll let you do like a step and catch up to you. So the very first thing I want you to do is figure out what that claim is, try to figure out then what the hypotheses are, and then I'll catch up. We've got a ton of them. Yay! All right, guys, so what is the claim that's being made? Yeah, we think it's changed from what it historically has been. It's historically been 38, so we think that the mean is now not equal to 38. Sample information will never show up in this step. Now, I know I have to give you the whole situation and the problem so you're able to do something, but in real life, we would make a hypothesis, then go get a sample to test it. So sample information will never, ever show up here. Because at this step in real life, we wouldn't have had the sample. Okay, now, which one is that going to be? No.
Oh.
Yeah, it's definitely the high. This is the complete opposite of an equal sign. This is a not equal to sign. So it's got to be the high. So what will the hoe be? Equal. So like somebody said, this will definitely be a two-tailed test. Two-tailed. Because either direction will show evidence because they think it's changed. Oh, lock it. Alright. Now, for this one, I very often get people say, you can use z-scores because we know the standard deviation. The standard deviation, that phrase makes no sense because there are two types. Which type do we know tells me what to do? Yeah, we know the population standard deviation, right? So that's known, and what else do I have to say? Yeah, sample is 46 greater than 30. Now, if the sample is less than 30, what do you look for? It's just got to say it's normal then. If neither one of those things is true, you still do the problem, to be honest, but you just put, I don't know if this is normal or not, but I'm just going to do it, you know. So on a test, I have to be very careful. I would never make a problem on purpose where I'm like, if you don't realize it, you're going to do it, but if you don't have to do it, no, that's just evil shit, right? I'm not that evil yet, no matter what you think. So I try to be really careful about not making a problem be like a trick problem. Like, you wouldn't have to do anything if you just realize it's not normal, haha, no. You're going to always do it. But if you're like, I don't think you can say something just to cover your ass, but they should always be doable. So this means, what do these two together mean I can use? Z-scores. Right. So do I need degrees of freedom or anything like that?
No.
Hell no. The Z-scores. I just go straight to the bottom of the chart, right? So I know the alpha here is what? 0.05 in this case. It's a two-tailed test. What are the z-scores I'm going to use then? Two-tail? 0.05? Yeah, 1.96. Right, you guys see that? Two-tail, 0.05, all the way down and get a z-score of 1.96. It should sound familiar. So when I say define the rejection region, this is what I mean. That picture, that's the definition. Now put it into words also. If the z-score I get from the sample is greater than 1.96, or it is less than negative 1.96. If it's outside of there, that would be unusual, right? So this is the same idea as unusual. We're just being more specific about where unusual starts. So for this problem, unusual starts at negative 196 and 196. If either one of these happens, then we can reject the hope, support the high. You can always set on proposition. All right, so what do I know from the sample now? Try to get the z-star by yourselves.
Not really.
You could look back at what we did before.
On top of the same thing. I don't know where we got that information. Okay, and the other color?
So yeah, X bar, because they told us. So what do we know from the sample? N is 46. Keep going.
Wait.
I think we know. Yeah, I mean, N is 46. What's X bar?
X bar is
From the sample up there.
this one?
Yep. X bar means mean, sample mean.
Mean.
11. And what's S? I'm sorry, sigma, because you have some population here.
What's the difference? Like the
S is sample, sigma's population.
Okay, because I always.
So here they know they told us standard deviation for the population.
Population is, I thought it was standard deviation too, I know what to,
You thought what?
the sigma was standard deviation for the. sample.
Yes, it is. S is standard deviation for the sample.
Yes.
Sigma is standard deviation for the population.
In other words.
And now you want to convert that to sigma sub x bar
So this one, like that?
over the square root of n. This way.
This one?
Yep. You got to divide that standard deviation by square root of n. To convert it from a spread for individuals to a spread for groups.
C means the population, and the S means the sample. So that's what the two that I got mixed up.
Yes.
40, the sample, the S. They take the sample. So the N is how much we have, how much, you know, it is, it says the sample, but it's like how much.
What do you guys get for that new standard deviation? Yeah, either 3301 or 3307. It's got to be at least 3 decimal places, so 4 decimal places is correct. I see 3 because I'm lazy. You'll start to realize this little list I keep making for step D is always the same. It's just that sometimes this will be S and S sub x bar, but sample mean, size, standard deviation for the individual, standard deviation for the groups, and that's the one I got in. Z star equals our data, 37.33, minus, and what's the mean? 38, because we assume it's going to be 38. Divided by. Yeah, this problem is 3 heavy. So you get 167 divided by that, negative 203? 2.03?
No.
2.4? Oh, that's
You know the formula is for this one?
2.02?
That's the one.
Alright, do we make it far enough away? Yeah, if you plot this, here's 0, negative 202 would be back here somewhere. So we made it far enough away. It's outside that range of what would be usually expected if the mean really was 38. So this is evidence that the mean is actually not 38. That's why we support the high, reject the low.
So support the high.
And of course, which one was the... Well, actually, before we get too far. Now, on that last problem, that was a t-score. And I'm not going to ask you for the p-value of a t-score. I'm just going to say this once, just to see if some of you guys realize. That t-score chart is nowhere near as detailed as the z-score chart. Because in order for that to happen, for every degree of freedom, I'd have to have blown that thing up to be the same size as the z-score chart for every degree of freedom. So you can't get a t-score for every specific, a p-value for every t-score you get. So z-score problems, I will ask you for the p-value, even though I didn't do it here, I'm just going to still do it. Can you guys get the p-value? And this is a little bit freaky because it's a two-tailed deal. Oh, shit. Let's see if you guys realize what happens here. So my z star was negative 202, right? So what's the area in this tail? The area in the tail of my z-score is related to the p-value. So what area is in this tail? I think I gave away my last z-score chart, so I can't even tell you. Do it in? 0217. Independent verification. He's looking at me like a deer in headlights. Can you look at negative 202 on the z-score chart and make sure it's 0.0217 area? It is? Okay. That is not the p-value because to make it fair, I've got to double it because this is a two-tailed test. So what is 0.0217 times 2? Point 0.0434. That is the p-value. Now let me see if this makes sense here. So, if I know what far enough away is, so in this case, far enough away was what was it? 1.96. I'm thinking about that last one. All right, either direction. I took alpha. Where's alpha on this picture? Where's alpha in this picture? Yeah, it's there. In both, right? So alpha is the area in the tail of what far enough away is. The p-value is the area of the tails of my z-score. So now watch. If I get inside, will my tail be bigger or smaller than the alpha's tail? If I'm inside. Well, my tail, I'll just look at it. So here's if I zoom in, here is the alpha, and here's my star. Is my tail bigger or smaller than the alpha's tail? Smaller. Doesn't make sense that every time I'm in there, I'm further away, so my tail will be smaller. Period. So, why did I reject this? Because our z-star was further than what was needed. But another way to check it is if p-value is less than alpha. Alpha is kind of like a maximum accepted probability that the mean is in the right place.
How do you know when to put fail, reject?
So remember, what is this thing called? This area? This region? What's this region called? The what region? You can look at, the rejection region. You can look at the step where we created it. So that's the rejection region. So if I make it in there, I reject the null. So if I don't make it in there, I fail to reject the null. Yeah. The null always thinks it's in here somewhere. So if I'm in here somewhere, I can't say the null's wrong. But if I'm out here, that's evidence the null's wrong. So you have a hand up. Are we all right? So you always see p-values reported, like I showed you from the studies we looked at last time. The p-values are what's reported because the alpha is what each of us own. One guy might say, I need 0.05 evidence, and somebody else is like, I need 0.01 freaking evidence. And he's like, well, okay, whatever. And it's sort of like what I talked about. If I'm the insurance company and you want to save money, you want to take money away from me, I'm the insurance company, I got to take your money. I'm going to make it really hard for you to prove that things have changed and your premium should come down. Does that make sense? I'm going to make alpha freaking 0.005 or something crazy. Right? Well, my favorite example, if I'm in a nuclear power plant, I'm probably going to make alpha 0.20. The minute it gets out there, oh shit. Right? I don't want Godzilla and all that shit to happen. All right. Bryan Cranston dies. Did you not know it was his wife that died? Bryan Cranston?
What are you trying
Godzilla? No, not the Matthew Broderick one. All right, guys. So whenever you have a two-tailed test, you got to double that area to get the p-value. Now look at this. What was alpha again? For this problem, what was alpha? 0.05. Isn't that less than that? That's another way to say that we rejected the null. Support the high. It'll be the same exact answer either way you look at it. Compare z-scores or compare areas. Same answer. So what's my conclusion? Did we make it? Did we succeed? Yes, we have found sufficient evidence. To do what? What was my claim?
The assembly term is changed.
Yeah, my claim was the high, so I want to use this language. We have found sufficient evidence to support the claim that what? Like you said, like I heard somebody say. Claim that the assembly time has changed. You can say changed from 38 hours or whatever, but it has changed. So if I was testing a drug, this might say we found sufficient evidence to support the claim that this new drug relieves headache pain in less time. Right? That would be, it's been clinically proven. Well, this is the clinically proven part. Right? Okay. I think I'm gonna hold off. Here's the pain reliever problem. Yes, ma'am.
You said if the p-value is greater than, right?
If the p-value is less than alpha, yeah. Remember,
It's the fourth.
the p-value is the probability that the mean is in the right place, and I just happened to get a sample that was there. So the smaller the p-value is, that means the less likely it is that the mean is in the right place. So if the mean's in the right place, p-value is the probability of getting sampled where I did. Right? So the smaller that p-value is, the more evidence that is that this guy is in the wrong place. Right? So if I get a p-value of 0.01, that's a 1% chance that the mean is in the right place. So what's more likely? The mean is in the wrong place. That's why we would reject the null. We reject the one that thinks it's equal to this, that's included in its statement. Yes?
You double it because it was 2, 2?
Did I do? For the p-value, you double it to make it compare to the alpha because it's 2 tails. It would be an unfair comparison to alpha if you didn't double. Yeah. All right, so let me give you this. I think we're not going to do that. I want to get you guys doing this group worksheet. If you really want to be a group of one, you can.